Welcome to my talk. I want to talk to you about things you can do to improve your code and your software design. I would like to be in Brazil now, I think. Here in Switzerland, we have snow. Everything is white and it's quite cold outside. But yeah, do you remember when you learned programming? In the beginning of our coding journey, we learned the basics, the theory, we learned some language and grammar, and how to put some logic into code. And then we have this kind of magic moment where we can get things done. We can build something, and it's working, and it's great. And then, next step. Mostly we get some job in the software industry, jump right on a project or begin a startup. And often we go straight into the deep end. We have time pressure, we have to get things done, we need to build the next feature, we have to deliver. So in software development, the user does not see our code. They mostly see some UI. And yes, you can deliver something faster if you don't test it and if you don't improve it. But how can you improve while being on a project? During the project, you maybe learn a new tech, a new framework, but that's mostly it. So how can we write better code? How can we learn it? How can we get better? Maybe there's a book or a video on YouTube to gain the knowledge. And then when we have the knowledge, we write better code. Maybe? Let's have a look at other disciplines. Let's see how they do it. How do they get better? So how do you get to be an all-star sport person? Obviously, you need fitness and talent helps, but the great athletes spend hours and hours training every day. They practice. They know and learn the theory, and yet they train over and over again. How to be a great musician? Yes, of course, it helps to know the theory, and you have to understand the mechanics of your instrument. It helps to have talent, but ultimately, greatness comes from practicing, applying the theory over and over again, using feedback to get better every time. So greatness comes from practicing. Learn the theory over and over again. We, as software developers, need to find ways of splitting the practice from the profession. We need practice sessions, sessions where we can concentrate on learning instead of the next most important feature and getting things done. In the software development, this is called a code cutter. A cutter is an exercise in karate where you repeat a form many times, making little improvements in each. And the intent behind the code cutter is similar. Each is a short exercise which you repeat over and over again. A very well-known cutter is the Fizzbuzz Cutter. You may all know it, but the Fizzbuzz Cutter says, write a program that prints the numbers from 1 to 100. But for multiples of 3, print fizz, and for multiples of 5, print buzz. For numbers which are multiples of both, print fizzbuzz. This is a task. Sounds easy, or? So doing this cutter, you just implement the functionality. And you can do it on your computer and in your IDE, or you can do it outside of your development setup. I love the Cyber Dojo. In the Cyber Dojo, I'm not disturbed by my IDE and all the tools around it. This way, I can concentrate on practice. So the Cyber Dojo supports a lot of different languages and frameworks, and a lot of cutters are there too, but it's a very limited editor. You will be forced to write new classes by your hand. You cannot just generate them with your IDE. But the most important thing, wherever you do it, please do the cutters. My advice is to do the cutters on a regular basis. Like sport, start it with once a week, but please do it regular. Time-wise, I love the Pomodoro technique. This is the thing where you work in usually 25-minute portions, followed by a small or bigger break. A Pomodoro is ideal for a coding cutter. So when you do a cutter, the outcome is not that important. It is important that you finish the task. It is not important to deliver a solution. Just do it time-boxed. So you can do the coding cutter for 25 minutes and then you stop. The next time you start all over again. Of course, you can also do 2 Pomodoros or 3. When you want to improve, start with coding cutters. A Pomodoro a week is all you need. And then when it is too easy and your Fizzbuzz looks like this Java with streams, or like these more classic Java examples with some loops and some conditions. So when you write this kind of code, please do me a favor. Think about the testability of your solution. How easy is it to test this program? Here, the code is a mixture of I/O and logic with more or less duplication. And this is the direct way to technical debt. It will be very hard to test this code. It will be very hard to refactor this code. But how do we write code that can be tested more easily? So luckily, there is also a well-known technique for this. We just write the test first. This technique is called TDD, test-driven development. And in theory, it is a very simple technique. Let me explain you the theory. Test-driven development has 3 rules. Rule number 1, write only enough of a unit test to fail. Rule number 2, write only enough production code to make the failing unit test pass. And rule number 3, refactor only when all tests pass. So that's it. Most of the time, you will be in the refactor phase and write better code. So do code cutters with TDD, write the test first, do little steps with many increments. And like before, do it regular and time-boxed. Just add the TDD to the cutter. Doing these exercises always alone is maybe not so funny. In other professions, we often practice together with other people. And the same is with code cutters. You can do the code cutter together with other programmers. Together it makes more fun, builds a common understanding, and it fosters the learning. So when doing it in pairs, I love to do the ping-pong pairing method. The ping-pong pairing is a technique where 2 people work together on a piece of code. A writes a test, then B implements the code, and together they refactor the code. Then B, the person that implemented the last code, writes a new test. And then A is in charge to implement it. Afterwards, they refactor together. And then it starts all over again. So they play like ping pong, write the test, implement the code. Write the test, implement the code. If you like, you can also try the mob programming style and do it in a bigger group. So the first step is doing the code cutters. The second is doing the cutters with TDD. Now we come to the third step. The third step are the object calisthenics. The object calisthenics are constraints that you apply during the cutter. They are formalized as a set of 9 rules. So when doing code cutters with TDD is too easy, you can simply apply them in your exercises. Let's have a look at the details. As said before, the object calisthenics are a collection of 9 rules. And you are free to choose the ones you would like to apply. You can apply one or two, or you can even apply all of them. But don't be too greedy in the beginning. Rule number 1 says only one level of indentation per method. So in this example, we do too much indentation. We have to remove at least the second loop. Martin Fowler, in his book Refactoring, introduced the extract method pattern, which is exactly what we do have to do here. We have to extract code into other methods. You won't reduce the number of lines, but you will increase the readability in a significant way. The board method is now easy to read and to understand, and the details are in some other methods. Rule number 2 says, don't use the else keyword. This is also about readability. It is often much easier to add a new branch to existing code than to refactor it into better solution, and you end up with really bad code. I've seen methods with 1,000 and more lines and dozens of branches in the code, and it's just impossible to understand it easily. You have to read and scroll and read and remember, scroll back. It's no fun. So constrain yourself and don't use the else keyword. Have less branches in the code. This way, you cannot introduce too much branches, and this rule is best combined with rule number 1. Rule number 3, wrap all primitives and strings. So following this rule is pretty easy. You simply have to encapsulate all the primitives within your objects. And when you do that, you also avoid the primitive obsession antipattern. This helps you to find a place where you implement the behavior of your primitives. Rule number 4, first class collections. Any class that contains a collection should contain no other member variables. If you have a collection of elements and you want to manipulate them, just create a class that is dedicated for this collection. And each collection gets wrapped in its own class. Now behaviors related to the collection have a home. You can filter or you can apply a rule to each element. Here lives the business logic to this collection. Rule number 5 is called 1 dot per line. Basically, the rule says that you should not chain method calls. However, it doesn't apply to fluent interfaces or more generally to anything implementing the method chaining pattern. For other classes, you respect this rule. It is the direct use of the law of Demeter, saying only talk to your immediate friends and don't talk to strangers. Instead of changing the methods together, we can write a method in the location class that knows how to add itself to the string buffer. This way, the board class does not have to know the details of the location, and we respect the law of Demeter. Next is rule number 6. It's very easy. Don't abbreviate. So naming things is hard. That's right, but naming things by their right names is even harder. And there are a lot of good guides on naming things in the software. So here the rule is just don't abbreviate. That's all. Rule number 7, keep all entities small. No class over 50 lines and no package over 10 files. Well, yeah. Sometimes I would prefer to have some more lines, and I usually take it to 150. But that's up to you. You can bend the rules. The idea behind this rule is that long files are harder to read, harder to understand, and harder to maintain. And the longer files tend to violate the single responsibility principle. So Keep the entity small. Rule number 8, no classes with more than 2 instance variables. This rule sounds easy, but it's probably the hardest one. So it promotes high cohesion and better encapsulation. 2 is just an arbitrary choice that forces you to decouple and your classes a lot. So in the beginning, you can also say 3 or 4 and decouple a bit less. And now to the last rule, rule number 9. It says no getters, no setters, no properties. This means also no public fields in Java. It is okay to use accessors to get the state of an object as long as you don't use the result to make decisions outside of the object. And any decision based entirely upon the state of one object should be made inside the object itself. That is why getters and setters are often considered evil. Then again, they violate the open and close principle. In the code, the get score is used to make a decision. You choose how to increase the score, instead of leaving this responsibility to the game instance. So a better solution would be to remove the getters and setters and to provide methods that make sense. Remember, you must tell the class to do something and you should not ask. In the following, you tell the game to update the score. It's the game's responsibility to determine how to update the score. Now you know the object calisthenics. Try them in your cutters or even apply them in your real-world code. It's just a matter of practice. Some rules are easy to follow and may help you. So let's wrap up. Step 1, do code cutters regular. Just go and do it. Step 2, enhance your code cutters with TDD and write your test first. And step 3, apply one or more constraints from the object calisthenics. This way you will write better code and will design better software. Thank you very much. Please feel free to contact me. Please follow me on Twitter and connect with me on LinkedIn.